Hello, so today I'm going to airbrush the armor of this snowtrooper model that I 3D printed and primed last time. With airbrushing there is an interesting link to my research in fluid mechanics. So what airbrush does, it creates what we call the particle-laden or droplet-laden jet of air that is that spray of paint. So the inside of this container there is a paint. I'm going to use this one, the Vallejo white paint. I'm going to put it there, and it's largely gravity driven into the main channel of the airbrush. So this is the trigger. Pushing on it kind of creates an airflow. You could regulate how much air flows through this channel, and the high-speed flow of air inside creates a low pressure zone, so it draws the particles, draws the paint in, and because of the high-speed flow it atomizes it, so creates the microscopic droplets. And the important part of the airbrush is this needle. I need to insert it in before starting. So this needle sits in the middle of the jet, so the paint droplets embedded in the air jet are flowing around this needle, and with the trigger I can regulate by how much the needle protrudes in and out of the nozzle opening of the airbrush. What that allows me to do is to focus that jet, focus the spray of the paint. So this narrowing down of the needle towards its point causes the flow to follow the surface of the needle. This is so-called Coanda effect. And at some point there will be a narrowest point, kind of the waist of the jet, that allows creation of very thin lines. The tricky thing with airbrush, anyone who has used one knows that the annoying thing that sometimes it splatters paint, so it causes the droplets to become too large essentially and create this kind of splatter pattern on the surface, which is, well, sometimes it's an artistic effect, but for miniatures like this is certainly undesirable. There is this optimal operating regime for an airbrush. So when we talk about airflow, like jet flows in particular, one of the important parameters is the so-called Reynolds number. And the Reynolds number is the ratio of the inertia effects in the flow to the viscous effects. And in general terms, if I describe it very generally, if the flow is very fast or the characteristic length of the object is very large, then the Reynolds number would be large, and the viscous effects are relatively unimportant compared to the inertia effects, and vice versa. So for the flow to be controllable and the size of the droplets to be relatively small, the Reynolds number needs to be sufficiently high to create the atomization of the paint. But as it impacts the surface of the model, when the spray of the paint impacts the surface of the model, we want the Reynolds number there locally to be low, because if the droplets are coming in too fast, they will splatter. So that is why the airbrush will be connected to a compressor here, and the pressure setting on the compressor typically needs to be low. So it depends on what specific compressor you're using. I'm using the Iwata compressor that has a pressure gauge there, and for me it's about 15 psi setting there. So that, again, this is very relative, and some trial and error is required. But here you go, I find more and more that this modeling hobby has many connections to my research and teaching in fluid mechanics, and certainly jet interaction with surfaces, printing, painting, so particle-laden jets are a large part of the engineering applications. particularly nowadays with bioprinting, but also more conventional applications like cooling of the surfaces, conventional printing. So, interesting example. Anyway, stay tuned, and I'll update you on the progress on this model.